Hello everyone, in this video we're going to talk about for loops, which allows us to execute blocks of code a specified number of times. This is useful because it saves us from having to write certain lines of code over and over again, and allows us to write programs that are able to handle varying amounts of data each run. For loops are useful for iterating through code specified number of times or for iterating through data structures. Let's start off with a very basic example. So here we've got a list of 10 numbers, 1 through 10. And then right here, we've got a for loop where its goal is to just print out each element of that list. So we start off with our keyword for, and then we specify an iterator. And this iterator can be whatever we want to call it. In this case, I just used the letter X. You can use any single letter you want. You can use a full name if you want. Some people, including me, would recommend using a full name to make it more clear what it is you're iterating through. So if say you got like a list of ships or a dictionary of ships with information, then you want to say for ship in that list or dictionary or something like that. Or if you got a list of names, you would say for name and list of names or something like that, just to make it clear what it is you're coding for. But you can pretty much use whatever you want. In this example, I'm just using the letter X. So we've got for X, which is our iterator, followed by the keyword in. In is for us to specify what we're iterating through. In this case, it's the A list. So we write in a list. So after we specified what it is we're iterating through, we add a colon, then a new line. And then after we add a new line, we have to add an indent, just like we would with conditionals, because we have to create a code block to execute under the for loop. And then after we add that indent, we can just start typing our code. And we can have as many lines of code as we need under the for loop. We just have to make sure they all maintain the same level of indentation, just like with conditionals. So what this is going to do is it's going to take each element in a list, assign it to X, and then we can do whatever we want with that X. So we can print it out, we can use it in an equation, we can do other things with it. Whatever it is we want to do, we can do it inside the for loop. And then after the last line in the for loop code block is executed, it will go back to the top, move on to the next element, assign it to X, and then repeat the process. So if I run this, it prints out each number 1 through 10. We can pretty much use all data structures inside of a for loop. For example, we've got a tuple. We've got a tuple with different colors. And just like with the list, we're just iterating through all the different colors and printing them out. With dictionaries, we have many different options on how to iterate through it. By default, we can do the same thing as we did with the list and the tuple. For name in ships, and then print out the information. So the way it handles a dictionary in this example, so it's going to iterate through all the keys inside the dictionary and assign it to name. And then we can do whatever we need to do by using name. So in this case, we're just printing out the name because it's the key. And then we're using name as a key inside ships to pull out the data. So if I run this, it prints out the key hawk and gives us the data for hawk. Same with Polaris and same with Baron. Another example of dictionary is the keys function. All dictionaries have access to this function, and what it does is it returns a list of the keys inside that dictionary. It's pretty much the same as our previous example. It gives us a list of keys, and we iterate through that list of keys. And we pretty much do the same thing as we did before. We print out the key, and then we also use that key to access the data. So it's pretty much the same. Another function that dictionary has is the values function. This will return a list of the values in the dictionary. So instead of returning us the key, it will just give us the value here. So if I run this, we can just print out the values. Finally, dictionaries have the function items, which will return both the key and the value. So you can have multiple iterators provided you're calling a function that will return multiple values for both those iterators. So in this case, we can print out the key and the value separately. And it's pretty much the same as the first two examples. But iterating through data structures is not the only thing that for loops are for. Sometimes we just need to repeat code over and over again a certain number of times, in which case that is where the range function comes in. The range function allows us to specify a range of numbers and is most often used with for loops to help Python count through the number of iterations it's gone through. The most basic range function call would be something like this one right here, where we create a range of 10. Because of how Python works, 1, it's zero-based indexing, so that range will start at 0. And 2, range will always return the number just before the number specified. So in this case, it will be 0 through 9. And in this example, we specify a min-max for the range. So we will start at 5, but we will end at 14 because it's always going to be just the number before the max specified. And as shown in this example here, we can actually count down as well. So we're specifying a range from 10 to 0, and we're counting down. We do this by specifying 10 as our first number, and then -1 as our max number. So that way we will create a range from 10 to 0. And then we specify an interval of -1 so that it knows to count down. And I'll show this in this example right here, but the reason I am demonstrating this like this instead of just printing out as a cast set is because when I cast it as a set, it prints it out in ascending order rather than descending order, which is what I would like it to do. And same with this one too. But what first I'll tell you what it's doing. What we're basically doing is we're specifying a range of 4 to 10, but at an interval of 2. So we'll get 4, 6, 8, and 10. And the reason I'm printing it out like this because like this one, it does something a little weird. But in order to explain what it's doing with this one, I'll have to show you. But for now, let's demonstrate what this block will output right here. So we've got our range from 0 to 9 for the range of 10. And then this one, we've got 5 to 14 for our range of 5 to 15. And then for this one, we go through a for loop to count down from 10 to 0. And then for this one, we count up by 2 from 4 to 10. So 4, 6, 8, and then 10. And then here's the weird casting issues. I only cast it to a set just so it will print out the numbers, because if you just print out a range, it will just say range whatever it is you specified. So you have to cast this as a set in order to print it out the way I did. But if I run this, as you can see, it prints the first one out in ascending order rather than descending order, even though we specified it as a countdown. And then for the second one, it jumbles the order for some reason. I'm not entirely sure why, but when you use it in a for loop, it will use it correctly. So it will count up from 4 to 10 by 2, and it will count down from 10 to 0 when you specify it. I don't know why it prints it out this way, but it will work properly in a for loop. So I've got a couple examples using a range in a for loop. The first one is calculating the factorial of a number. For those of you who don't know what a factorial is, it's basically a single number equation where you got a number followed by an exclamation mark. And what it means is that you basically start with that number, say factorial 5, like you see in the code. So basically it would be 5 times 4 times 3 times 2 times 1. You don't do 0 because obviously every answer would be 0. And you just multiply those numbers together. Likewise, say factorial 10. It would be 10 times 9 times 8 times 7 times 6, so on until you get down to 1. And then you get your answer. So that's what a factorial is. So there's a couple ways to do it in Python. The way I did it was this. I set a factorial variable name to equal 1. And then I create a range to count down from 5 to 0. So the result in the numbers will be 5, 4, 3, 2, and 1. Now the reason I do it like this is because we have to set factorial by default. If we were going to calculate the factorial of 5 every single time, then we could just set factorial to 5 in the beginning before the for loop, and then create a range from 4 to 0 instead. But if you wanted to be something more dynamic, so that you can calculate the factorial of any number provided, then you would probably want to set something up like this. And instead of specifying 5, you would say, specify a variable storing the number that you want to calculate each time. In this example, I'm still specifying 5, but you can do it any way you want. This is just the way I'm coding it. So this will multiply 5 times 1 starting out because, you got to start with 5. And then you count down 4, 3, 2, and 1 and calculate the rest. Technically, we don't even have to include 1. So I could technically change that 0 to a 1 and it wouldn't even matter because the 1 just results in itself. But when we run this and it prints out, the answer will be 120, as you can see here. Now our second example right here, you might find a little bit interesting. So we've got a list of numbers and I'm using the function length to get the length of that list. So in this case, it'll return an 8 because there are 8 elements. And then we're passing that directly into range. So we're creating a range from 0 to 7. And then we're iterating through that list of numbers to access the elements in this list here. As you can see here, we're printing out each element and then we're changing that element to 0. And that's the reason why you would want to iterate through a list in this fashion, is if you want to modify the list itself. So if I run this, it'll print out the numbers, but then it'll print out the whole list after the for loop and it'll show you that everything's been changed to 0. The only way to modify the list is to do it this way. So we have to use range to help us iterate through the indexes rather through the elements themselves. So we can iterate through a list of the indexes and then use the index to access the element in the list and then modify it as we please. If we were to do it the other way, as I showed in the beginning of the video, where we iterate through the elements themselves. So I'm iterating through that list with x as each element, and then we try to set x to equal to 0. X will successfully be set to 0, but it will not affect this list. So if I run this, as you can see, the list is unchanged. So if we want to be able to modify the list, then we have to use range to iterate through a list of the indexes rather through the list itself. Now we've got two other keywords to talk about when it comes to loops in general: break and continue. So what break will do is it will break out of the loop completely, preventing the rest of the iterations from executing. And continue will skip over an iteration and continue on to the next iteration. In order for both these keywords to work properly in your code, you typically would have them under an if statement. The if statement would check for some sort of condition going through a loop iteration, and if that condition is met, then it would break out of the loop, or it will continue through the loop. You wouldn't just have them sitting inside the loop. Otherwise, the loop would never run properly, unless that was your goal. But in that case, it wouldn't make much sense to have it like that in the first place. So I have an example of the break. So we've got a list of numbers, mostly positive, except for this -1. And then we've got this for loop where we're iterating through the elements in the list. In the for loop, there is a print statement, which will print out the elements as it comes across them, but it's also got an if statement. The if statement happens first. What it does is it checks to see if the number is less than 0, basically looks for a negative number. If the number is negative, it will break out of the for loop, effectively ending the for loop, and it won't print out any more numbers. But until it evaluates to true, it will print out each number. So when we run this, we will get 6, 3, 4, and 5. But once it hits -1, it will break out of the loop and it won't print out any more numbers. See? The break keyword is a pretty useful keyword to have. Basically, if you are iterating through a whole list of data or something and suddenly you come across some invalid data that would otherwise cause the whole program to not work properly, the data results you might get will be completely messed up from it, then break is a good way to just break out of that loop so you don't waste time waiting for it to figure that out, and then you can just exit out of the program after the fact. So it's a very useful keyword to have. Continue is also pretty useful though. Continue allows you to skip over data in case you come across something that can't work. You don't want to actually try to close out the entire program or break out of the loop completely. You just want to skip over that one data set and then move on to the next one. That's what we can do here. So in this example, we've got another list of numbers, basically zeros and positive numbers. So what it will do is it will print out any number that's not equal to 0. If it comes across a number that's 0, then it will continue and skip over the print statement and go to the next iteration. So when we run this, we should only see the numbers printed on the screen that are not 0. See? 1, 3, 5, 8, 9. All the zeros were skipped. One other thing to talk about is nesting. Like with conditionals, we can nest loops. When it comes to nesting loops, there's no limit as to how many loops you can nest under each other, but you don't want to nest like 5 loops directly under each other like that. But nesting is something you can do. It's very useful. Just be careful with how you do it. This basic example right here will show you how to nest one loop under another loop. Basically, inner loops will go through all their iterations first before the outer loop can go through its next iteration. For every x, y is going to iterate a certain number of times. So when we have x equal to 1, y is going to be equal to 1, 2, 3, and 4, and then we'll print out the statement 1-1, the 1-2, 1-3, and 1-4. Then x will iterate to 2, and then y will go through its for loop again. So it'll be 2-1, 2-2, 2-3, 2-4, and it'll just keep going like that until finally x has completed its final iteration, in which case nothing else will iterate. So if I run this, we get 1-1 to 1-4, 2-1 to 2-4, 3-1 to 3-4, 4-1 to 4-4. And that's nesting. And that's it for for loops. I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to the Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.